So, what you learned, or what you had to use, was you had to use the formula pH equals negative log of H plus. How many use that formula? Okay.
It took me forever to figure out how to do the reverse.
Yes, we're going to talk about that. Thanks for bringing that up. pOH is the negative log of what? OH. Okay? What would be P June?
Negative log.
Negative log of June. That's right. Okay? What would be P Maruna? Negative log of Maruna. Okay? So, don't let this whole pH or pOH thing intimidate you.
The P of summer would be the negative log of winter.
Actually, yeah, okay, all right. That'd be like a pH and a pOH. Okay, now, guys, you might encounter this, pKa. What is pKa?
Of a weak acid.
The negative log of what?
Of weak acid.
Ka. What's pKb?
Negative log of Kp.
Negative log of Kb. So all P means is take the negative log of something. Okay?
Bless you.
All right. Now, what we kind of started in the middle because you guys were already so good at doing rice boxes and doing K values. We just switched to Ka rather than Kc or Kp. But now we're going to back up a little bit and figure out where all this H plus and OH stuff comes from. Okay? What actually happens to water, even if it's just pure water, neutral water, is that it dissociates itself into H plus and OH minus. We call this the auto ionization of water, or auto dissociation of water. Okay? Now, it's almost undetectable. Okay? The K value that goes along with this reaction is 1 times 10 to the negative 14. We call it Kw because it's water dissociating. Okay? And that's actually the value at, I think, 25 degrees Celsius. Okay? And we pretty much use that value all the time. It would just be kind of a weird extension question if they said, hey, at 40 degrees Celsius, the value is this, work with it. Usually, you don't have to worry about that. Okay, so, I want to ask you, if we're talking about neutral water, actually, no, let's not start with neutral.
Alrighty.
If we're talking about an acid, and like an acid solution, okay? Believe it or not, it will have water in there, they'll have H plus, and they'll even have some OH minus in there. But what will be true about the H plus concentration versus the OH concentration if it's acidic?
It's higher.
It's higher. Very good. Okay? So H plus concentration would be higher than OH minus concentration if it's acidic. If it's basic, what would be true of the H plus concentration? It would be lower. Does that concept make sense to you? Okay, and it is supposed to be that simple. Okay? What if it were neutral? They would be equal. Absolutely right. Okay. Now, I'm kind of curious as to what the exact concentrations are in neutral water. If they are equal, could we represent them both by an X?
Yeah.
Yeah. And we have a K value. Could we write a K expression? Yes. Now with the expression, remember, I want the chemical formula in there. So what would be my expression? What would go on top? H plus times OH minus, and what would be on the bottom? Nothing. Very good, because this is liquid water. These are aqueous ions. So there is no denominator, kind of like when we worked with KSP. Solids turning into ions. Okay, so that's our expression. So can't we say that 1 times 10 to the negative 14 equals x times x?
No.
That would work. So what would be your x value if you solved this?
Square root of.
So square root. Some of you are a little more familiar with exponents. If you take the square root, you actually are dividing by 2, aren't you?
Yeah. 1 times
So what do you
10
get for your x value?
1 times 10 to the negative 7.
1 times 10 to the negative 7 molar, and this would also be 1 times 10 to the negative 7 molar. Does that make sense?
Yep.
Even amounts. Okay, now, what would be the pH? What would be the pH of the neutral? 7. Have you guys figured out that, remember, log means what is 10 raised to? So if you're taking the log of 10 to the negative 7, it's negative 7, and then it says to take the negative of that. Okay? What's the pOH? It's also 7. Has anybody ever wondered why in middle school, when you probably first started talking about acids and bases and pH, why we said neutral was 7? Some people are like, why isn't it 10 or 5 or something kind of even? This is exactly why, because the data shows in lab, when they measure the concentrations of H plus and OH, they're always the same, and the KW is always 1 times 10 to the negative 14. It's a constant. Isn't that cool? Now, we don't tell you this in middle school because we'll freak you out. Okay?
And not make us take AP chemistry?
That's right. Okay, now let's make up some numbers. Let's go back to having an acidic solution. If it's acidic, can someone give me a possible concentration? Let's do 1 times 10 to the something.
2 to the 22nd.
Okay? Well, 22nd would be really low. But 10 to the negative 2, would that be, you guys said H plus should be higher than OH minus.
Yeah.
Would 10 to the negative 2 work? Sure. This would be higher than that neutral number, so it's more concentrated. If this is 1 times 10 to the negative 2, what would OH have to be? 1 times 10 to the negative 12, because the product always has to equal 1 times 10 to the negative 14. Make sense?
See.
Okay. And look at the numbers we picked. Is this greater than this? Yeah. Okay. Now, just for fun, what's the pH of this?
2.
2. Are solutions with the pH of 2 acidic?
Yes.
Yeah. Okay. Low pHs are acidic. What would be the pOH? 12. We're not used to thinking in pOH, but every once in a while we're asked to find it. Okay, let's do one more. All right. Let's make it basic. So can someone give me a number, a 1 times 10 to the something number, that for H plus, that would make it basic?
10.
T.
To the negative 2?
No.
Negative 2 wouldn't work.
Negative 10.
Okay, to the negative 10. Okay.
Uh,
Because that is lower than what it would be for neutral, therefore this would be
negative 4.
higher than what it would be for neutral. What would it have to be?
To the negative 4.
1 times 10 to the negative 4. You guys see how these add up to 10 to the negative 14. What would be the pH? Here. 10. Solutions with the pH of 10, aren't those basic? Yeah. And just for kicks and giggles, what's pOH? 4. Okay. Now I want to see if you are noticing a lot of relationships that are actually on your formula sheet. Okay? Do you see on your formula sheet the KW expression?
Yes.
Do you see the value given and that KW is always going to equal H plus times OH minus? Okay? What do you see? Do you see a formula that relates pH and pOH? 14 equals pH plus pOH. Let's look at what our examples right here. Does that hold true?
Yep.
14, 14, 14. Okay? So lots of good formulas right on our sheet. Does that make sense?